Good morning, dear students. My name is Ferhan Mazher, and today is 28th March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels physics, and today we have set our hearts to solve a theory paper, and we have selected October November 2013 a 2-2 paper. This theory paper belongs from the zone 2, and this is the second video on this paper. In this video today, we will solve the section B of this paper. The section A of this paper we have already solved, and that has been uploaded in my YouTube channel, and you can find that in the same playlist where you find this video. So, my dear students, before we go to we start solving this paper, I would like to thank you for taking out time to watch this video. And I will also like to tell you that in the description of this video, you will find the playlists of all the physics papers which I have solved. So if you are looking for a particular paper, you can go into the description of this video and you will find all the playlists which have the past papers. So let's start today's paper. Okay, so the first question coming up, this is section B of the October November 2013 2-2 paper. We are doing the section B, question number 9. Its A part is state what is meant by the moment of the force. The moment of the force is the product of the force and the perpendicular distance between the pivot and the line of action of the force. So that is called. So let's go to the question number 9. Sorry for this. Okay, so here we go. So our answer is coming up on your screen. He says product of the force and perpendicular distance between pivot and the line of action of the force. Moment is the product of the force and the perpendicular distance between the pivot and the line of action of the force. The anchor of a sailing ship has a mass of 350 kg. 6 sailors raise the anchor from the seabed by turning a large axle. They push the handles attached to the axle and it rotates. The anchor is on the end of a chain that winds on to the rotating axle. Figure 9.1 shows the sailors lifting the anchor. So what they are rotating this axle, and there is a chain. So with this chain, anchor is attached. So when they rotate it, the anchor is coming upward. Okay. So the distance where that man is applying force is perpendicular distance from the axis is 1.2 meter. There are six sailors. Each of the sailor exerts a force 750 Newton on his handle, and his handle at a distance of 1.2 meter from the axis of rotation. The the axle rotates through one complete revolution, and the anchor is lifted through a distance of 160 centimeter. The gravitational field strength G is 10 Newton per kg. Calculate the total moment exerted on the axle by the 6 sailors. So the force applied by one sailor is 750. So the moment produced by this single sailor will be F into D. The D is 1.2 meter. The force applied is 750 Newton. And there are 6 such sailors. So let me show you. Okay, so the total moment produced by them will be, the moment will be equal to 6 multiply the moment produced by the one sailor, and that is F into D. So 6 bracket 750 multiply 1.2. So it will be 5400 Newton meter. 5400 Newton meter. Hopefully you understand. So we can check the answer of this. Okay, so 5400 is the right answer. That is the definition. Okay, so let's go to the second part. He says the gravitational potential energy gained by the anchor as the axle rotates through one complete revolution. So when one complete revolution is done, the anchor, the weight of the anchor is given here. Yeah, the weight of the anchor is 350 kg. The weight of the anchor is 350 kg, and the anchor rises upward how much? 160 centimeter. So convert this vertical height into meters, and then I can answer this question. He says the gravitational potential energy gained by the anchor as the axle rotates through one complete revolution. So let me show you. Okay, so the gain in the potential energy will be mgh, and the mass of the anchor is 350 kg, and the g value is 10 Newton per kg, and the h is 1.6 meter. They have given 160 centimeter. In meters, when you divide it with 100, it will be converted into meters, and that will be 1.6. It will be 1.6 meter. So just multiply them. 350 multiply 10 multiply 1.6, it will be 5600 joules. So let's check. 5600 5600 joules. So our answer is right. So our answer is right. Okay, so next question. The work done on the axle by the sailor is very much larger than the gravitational potential energy gained by the anchor. State and explain how much energy is wasted. How energy is wasted, sorry, not how much, how energy is wasted. You see, there can be many reasons. There might be some friction between the axle and its axis, and you also have to lift the chain. You see, we have only calculated that the anchor is lifted upward, but you know the chain which is connected with the anchor, that chain is also very heavy. They are also lifting up the chain. So we have not considered here the weight of the chain. They have to lift the weight of the chain also. So there the energy is wasted. So let's check what the answer which I gave, and then we'll check it from the marking scheme. There is friction between the axle and its axis. To overcome friction, energy is converted into heat. I have only given one reason. There could be other reasons also. For example, I gave you one reason that chain which is attached with the anchor, that chain also has weight, and that chain is always very heavy. You might have seen in movies that the anchor is attached through a iron chain. So that iron chain is very heavy. They have to lift that chain also with the anchor. So let's check from the marking scheme. What the mark? He says that the friction at the axle, board to drag due to water. The anchor also feel the drag of the water, and chain lifted also, heat produced, ignore in sailors, or work done against friction, or work done raising the chain. So when you have done work raising the chain, your energy wasted. Then the next third part of the B part is explain why the power produced by the sailors is larger when the anchor is lifted at a faster rate. You see, when the same anchor comes up at a faster rate, the same amount of work done is done in the less time. The gain in the potential energy is gained in less time. So that's why the power will be more. The work done is work done in less time, so the power will be more. If the work is done in less time, the rate of the power will be more. Okay, so let's check the answer here. Work is done in less time gain in the potential energy of the anchor in less time. That's why the power will be more. So let's check the answer from the marking scheme. What the marking scheme? Same amount of work done or the potential energy in less time, or power inversely proportional to the time. Okay, so our answer is right. Okay, so let's move to the next part. He says, describe, the question is, that's the C part of the question number 9. They say, it's a 4-mark question. They say, describe with the aid of a labeled diagram how to verify the principle of moments. You see, if you want to verify the principle of moments, the method is very simple. You take a rod. You take a rod, and that rod, you put a pivot under that rod. You put a pivot under that rod in its center, and then you take two weights whose weights you know. You two different weights, the weight of those their load you know, and then you put those loads with the help of thread on both the left and the right side of the rod, and in the middle of the rod you have put a pivot, and then you move those loads, and you move both the loads until you achieve the equilibrium. Rod becomes balanced on that pivot. Then you note down that what is the distance of the weight 1 from the pivot, and then you check what is the distance of the weight 2 from the pivot, and then you multiply the weight 1 with the distance 1, and you multiply the weight 2 with the distance 2. You will observe that their product is same. The weight 1, for example, if you have hung the weight 1 on the left side of the pivot, so the weight 1 is trying to produce an anti-clockwise turning effect or moment. And if you have hung the weight 2 on the right side of the pivot, then the weight 2 is trying to produce a clockwise moment or turning effect. So you will observe that the clockwise moment and the anti-clockwise moment, they are equal to each other. This proves the principle of moments, which states that the body is in equilibrium. If a body is in equilibrium, the sum of the clockwise moments is equal to the sum of clockwise moments. The sum of the anti-clockwise moments is equal to the sum of clockwise moments. So it's a 4-mark question, and we have to write its answer. And let me show you the answer which I have written. So here we go. Okay. So the answer is coming up on your screen. You can see the diagram also that is showing up on your screen. It says, so you can see I have shown a rod, and that rod is, I have placed a pivot under the center of the rod, and I have taken a known weight W1, and I have hung it with the help of a thread on the left side of the pivot, and W2, its weight is known, and I have hung it with the help of a thread on the right side of the pivot. And then I have moved W1 and W2 in such a way that the thing has become in balance. The rod has become in balance on that pivot. So then I have measured the distance of the weight 1 from the pivot, D1, and the distance of the weight 2 from the pivot, D2. So I will note when the thing is in balance, you will observe that the product of W1 D1 will be equal to the product of W2 D2. In other words, you can say the clockwise moment will be equal to the anti-clockwise moment. Take two different loads, W1 and W2, and hang it on a rod which is on a pivot. Move both W1 and W2 such that the rod becomes balanced on pivot. Measure D1, distance of the W1 from the pivot. Measure D2, location and the pivot. W2 location, and actually W2 D2 is the distance of the W2 from the pivot. Product of the W1 D1 will be equal to the W2 D2. Clockwise moment will be equal to the anti-clockwise moment. So this is a 4-mark question. Please try to write a better answer. I have just given you an example that how you can write this answer. So let's have a look at the marking scheme, what the marking scheme has to say. The marking scheme says question number 9C part. It says clear label diagram with ruler, fulcrum means pivot, at least two weights, any three of the following points made in words. Balance ruler on its own, place weights on ruler so it balances. Clockwise and anti-clockwise moments equal or net moment zero. Repeat, apply similar principle to other possible methods. Okay, so our answer is good. You can write a better answer, but I always tell you, compare your answer, your teacher's answers with the marking scheme. I hope you will follow this. So we are done with the question number 9. So let's go to the next question. So the next question coming up on your screen, question number 10. Figure 10.1 shows an electric train of the mass 5.5 expo 5 kg. The mass of the train is given 5.5 expo 5 kg. The train is initially at rest. The electric motor exerts a constant force and the train accelerates. Its acceleration decreases until the train reaches a speed of 40 meters per second. The train then continues at this constant speed. On the axis in the figure 10.2, sketch a speed time graph for the train. So here we have a speed time graph and we have to sketch it. The train was initially at rest and then it started accelerating, and gradually the acceleration decreases until the train reaches a speed of 40 meters per second, and then the train continues with that constant speed. So we will draw a line here. We will start a graph from here. I will draw a decreasing curve and then I will make it flat. I will make it horizontal. So let me show you. So here you can see the train started at the rest and the gradient of this speed time graph is gradually decreasing, which means the acceleration is gradually decreasing. And here the graph, speed time graph becomes flat or horizontal, which means that the acceleration has become zero. And that means that the speed of the train has become constant. Here you can write that speed. The speed was given to us and I have not mentioned it here. Here you can mention that speed because we know that speed. That speed was how much? 40 meters per second. So you can write there 40 meters. You can write here 40 meters per second. Hopefully you understand. So here we go. So it says question number 10 and it's A part, start at origin and not horizontal. Gradient gradually decreases. Ignore sudden decrease, not if part of curve above horizontal section. Final horizontal section. Okay, so our answer is good. So let's start the next part. Let's look at the next part, what the next part has to say. He says, describe how the speed time graph for the train is used to determine the distance traveled by the train when it accelerates. You see the distance traveled, you can very easily calculate. Area under the speed time graph represents the distance traveled. Area under the speed time graph represents the distance traveled. So here we go. Area under the speed time graph is equals to the distance traveled. So very simple and straightforward answer, a very famous question. Okay, so let's have a look at the marking scheme. What the marking scheme says, it says the area under the graph or count squares under the graph between t equals to 0 and the horizontal section or when speed is changing, or calculate the equivalent distance to 1 centimeter square. So let me check. Okay. It was how many questions? Number 2 marks. How the speed time graph for a train used to determine the distance traveled by a train when it is accelerating. Okay, so when it's accelerating, this word is also important. So here in my answer, I have not mentioned it. Area under the speed time graph is equal to the distance traveled. find the, here add a sentence that find the area under the decreasing curve. Okay, because when the graph became flat, the train started moving with the constant speed, because they are asking when it was accelerating. So when it was accelerating, you have to find the area, this area, not this area. Find this area until the graph is a decreasing curve. Okay, so find the area under the speed time graph up to the point when the it's a decreasing curve. Add this sentence in the answer. Okay, I hope you understand. He says explain in terms of the forces acting why the acceleration of the train decreases. The acceleration of the train decreases because the train is gaining speed. If the train is gaining speed, you see what will happen as the train will gain speed, and the air resistance acting on the train, that will increase. And because the driving force is not increasing, but due to the increase in the speed, the air resistance is increasing. So the resultant force, which is the driving force minus the air resistance, resultant force is driving force minus the air resistance, because the driving force is not changing, but the air resistance, as you are moving with faster and faster speed, the air resistance is increasing. So the resultant force is gradually decreasing. That's why the acceleration is decreasing, because the resultant force is decreasing. Let me show you my written answer. Driving force is constant, but as the speed increases, the backward air resistance increases. Resultant force decreases. That's the reason. Let me check the answer. Question number 10, B, first part. Friction air resistance increases as speed increases, resultant force decreasing. The driving force was constant, okay? Remember that. The resultant force decreased. Okay. The next question is why the train eventually reaches constant speed. The train will eventually reach the constant speed when the air resistance will increase and it will become equals to the driving force. The resultant force will become zero and the acceleration will become zero and the train will start moving with a constant speed. When air resistance becomes equals to driving force, resultant force becomes zero. The acceleration will become zero and the train will start moving with a constant speed. Air resistance, he says, air resistance increases until net force becomes zero or force is balanced, or air resistance and the driving forward force are in equilibrium, balanced or equal. Okay, so next question. He says calculate the kinetic energy of the train when it is traveling at a constant speed. So when the train is moving at a constant speed of 40, you know the formula for the kinetic energy? Formula for the kinetic energy is 1 by 2 mv square. Formula for the kinetic energy is 1 by 2 mv square. We know the mass of the train 5.5 expo 5 kg, and we know the speed of the train is 40 meters per second. So very easily we can find the kinetic energy. Kinetic energy is equal to 1 by 2 mv square. 1 by 2 multiply 5.5 expo 5 multiply 40 square equals to, the answer will be 4.4 expo 8 joules. 4.4 expo 8 joules. So let's have a look at the marking scheme. 4.4 expo 8 joules. So our answer is right. As the train accelerates to 40 meters per second, electric energy supplied to the motor is converted into kinetic energy of the train. The efficiency of this process is 0.40, or you can say 40%. calculate the electric energy supplied to the motor. So the output energy we know is kinetic energy, the input energy is the electric energy, and the efficiency of that system is only 40%. So we have to calculate how much is the electric energy input. You know, the efficiency formula for the efficiency is a useful output energy divided by input energy multiply 100. The efficiency is 40% and the useful output energy is 4.4 expo 8 joules, and the input energy is question to us, multiply 100. So the input energy, take it to the other side and bring the 40 downstairs. So the input energy will be equals to 4.4 expo 8 multiply 100 divided by 40 equals to, and the answer you will get will be 1.1 expo 9 joules. 1.1 expo 9 joules. So the input energy will be this much. Let's check the marketing. 1.1, we have that 1.1 expo 9 joules. So our answer is right. Okay. Okay, so let's move to the next part. He says that the electric energy is generated in an oil-fired power station. Chemical energy in the oil is places where the energy is lost as heat in this process. You see, some of the, when you are boiling the water in the boilers, we use boilers to produce steam, and then with the help of the steam, we run the generators. So when you are heating the boiler, some of the heat energy is lost from the boiler to the surrounding, and the steam which comes out, that also has a lot of energy, heat energy in it, and that goes into the surrounding. So let's see what my answers are, and then we will check from the marking scheme. So the heat from the boiler goes to the surrounding. Exhaust gases also takes away the heat. So the where you are burning the oil, there the exhaust gases are produced, and that exhaust gases are also very hot. So they are also taking heat with them. So these can be two answers. So let's check from the marking scheme. Two valid examples. For example, furnace, boiler, turbine, generators, coils, cooling water, cooling towers, heat, exchanger, transformer, chimney, waste gases, transmission cables and lines, and for example, wires. Yes, when the current is flowing through the wires have some resistance and some electric energy will be converted into heat. So ignore power station, all the parts of the motor. Okay. So let's go to the next question. So my dear students, we are done with the question number 10. Now we are going to the question number 11. A metal filament lamp is connected to a power supply. The electromotive force EMF produced by the supply can be varied. And the figure 11.1 is the circuit diagram. What is meant by the electromotive force? It's a 2 marks question. What is meant by electromotive force? The amount of work done by the source of the electricity to move unit charge in a closed circuit is known as EMF of that source. So that's the definition of the EMF. Let me show you my definition. I have written this, the written definition. Okay. So question number 11A part is coming up. Amount of work done to move unit charge in a closed circuit by the source of electric energy is EMF of the source. So that's the definition of 2 marks. So let's have a look at the marking scheme, what the marking scheme has to say. Sorry. Here we go. So the marking schemes of work done per unit charge or coulomb, or energy transferred per unit charge or coulomb, property of a source of electricity, or energy transferred to electric energy per unit charge per coulomb. So hopefully you can understand this. The marking scheme question number 11A part is showing up on your screen. Okay, so we are going to the next part. He says add appropriate circuit symbols into the figure 11.1 to show the position of an ammeter that measures the current in the circuit. The ammeter is always connected in series. A voltmeter that measures the voltage across the lamp. The voltmeter is always connected parallel to the device, to the lamp. So I will put an ammeter here and I will put a voltmeter here parallel to this lamp. So let me show you. So you can see here I have shown this is the ammeter, this is the voltmeter. So the ammeter is connected in series and the voltmeter is connected in parallel to the lamp. Okay. So let's check the answer. Ammeter in series, voltmeter in parallel with the lamp, or lamp and the ammeter. Okay. So next question. That's the C part. A student adds meters to the circuit and makes measurements of the current and the voltage. He then plots the current voltage graph shown in the figure. So here IV graph is shown. The current is on the y-axis and the voltage is shown on the x-axis. Remember, the slope of this graph will be I by V, and that will be equals to 1 by R. So the slope is equals to I by V and the slope will be equals to 1 by R. So the slope is equals to the reciprocal of the resistance of this filament lamp. Okay. He says using the values from the figure 11.2, they are talking about this graph, calculate the resistance of the lamp when the current is 0.70 ampere. Give your answer to an appropriate number of significant figures. Okay. So when the current is 0.70 ampere, the current is 0.7. So it will be 0.6 and it will be 0.7. From here, come here. Check what is the voltage there. The voltage is 2 volts. So let me show you. Here we go. So I, from that graph, I can tell when the I is 0.70 ampere, the value of the voltage is 2 volts. So, you know, according to Ohm's law, V is equals to IR. So R is equals to V by I. So voltage is 2, that comes from that graph, and the current is 0.70. So when you divide it, you get 2.86 ohm. So it's approximately 2.9 ohm. So the resistance of the lamp at this voltage and current is 2.9 ohm. So let me first of all check. 2.9 is our answer. So our answer is right, sir. Okay, so let's move to the next question. He says, state what if anything. State what if anything happens to the resistance of the lamp as the voltage increases. You see, from this graph, I can say when the voltage is increasing, the gradient is decreasing. As the voltage is increasing, the gradient is decreasing. The gradient of this graph is equals to the 1 by R. So the reciprocal of the resistance. So whatever is happening with the gradient, opposite is happening with the resistance. So it means as the voltage is increasing, the gradient of the IV graph is decreasing. It means that the resistance of that lamp is increasing. Okay. So as voltage increases, resistance of the filament lamp also increases. Hopefully you understand what I have explained. Here they have resistance increases. So our answer is right. In a normal use, the lamp is connected to a 12-volt supply. Use the figure 11.2 to determine the power of the lamp when it is used in this way. You see now the voltage is 12 volt. When the voltage is 12 volt, so this is the voltage. So how much will be the current? 2 ampere will be the current. So if you know the voltage and the current, so you can find the power. P is equals to IV. P is equals to IV. The voltage is 12 volt. From that graph, I can tell that the current will be 2 amperes. So power formula is P equals to IV. So P will be equals to 2 multiplied 12, that will be 24. So the answer will be 24 watt. 24 watt is the answer, sir. Okay, so let's move to the next part. Okay, the next question. When connected to a 12 volt supply, harmonic emission occurs in the lamp. Describe what is meant by the harmonic emission. You see, when you heat a filament, and from that filament, the electrons gain kinetic energy and they come out of that metallic filament into the air. This process is called harmonic emission. Let me show you. When a cathode is heated, or you can say that filament is heated, electrons from the heated cathode or the heated filament come out into air. So this is called harmonic emission. Instead of using the word cathode, you can write the word filament. Okay. Let's have a look at the marking scheme. Emission of electrons from the heated metal, named metal or filament or wire. That's called harmonic emission. So our answer is right. Then he says that the harmonic emission is used in the cathode ray oscilloscope tube. State why the air must be removed from the tube of the CRO. You see, in the CRO, we have created vacuum or a very low pressure of the gas. The reason is we remove all the molecules of air from the CRO, because when the beam of electrons will be formed and they will travel from that, from where harmonic emission is happening, from the, we call it electron gun. From there, they travel towards the screen of the CRO. So if there will be air present, the electrons will collide with the molecules of the air, and they will, due to the collision, they will be stopped. So they will not be able to reach the screen. So that's why we remove all the air from the CRO screen, from the CRO tube. So otherwise, electrons will collide with the air molecules and they will not accelerate and they will not be able to reach the screen of the CRO. You can also write that. Prevent collision with the air molecules or prevent deflection or lets electron particles reach the screen of the CRO or travel unimpeded. I hope you understand. Okay, so let's move to the next part. He says a voltage is connected across the Y plates in the CRO. State and explain the effect on the trace on the screen. You see, when a voltage is given to the Y plates, the trace on the CRO screen moves vertically. It can move up and it can also move down. So when you connect, you give voltage to the Y plates, the trace of the electrons on the screen of the CRO moves up and down. It moves vertically up and down. It controls the movement of the electrons in the vertical manner. So you see, trace will move vertically up and down. So that is our answer. So let's have a look at the marking scheme. First of all, that was the moves vertically up and down, above, below line, not with the horizontal move. The Y plate do not control the horizontal movement. It only controls the vertical movement. So the particles will move up and down. So my dear students, okay, so dear students, today we have done October, November 2013 2 paper. In this video, we have done the section B of this paper. The section A of this paper we have already done, and that has been uploaded in the YouTube channel, in my YouTube channel. You can find that. And thank you very much, everybody. I'm trying to do the papers of the physics paper 2. I'm trying to do now the zone 2. The zone 1 I have already completed from 2021 to 2010. All the papers of the zone 1 have been completed. And now I'm working on the zone 2, and I hope before your papers in the May June we will complete up to 2010. All the paper 2 of the zone 2 will be also completed. So thank you very much, everyone, for your appreciations, for your comments, and for watching my videos. Always remember, subscribe my channel, share the link of this video with your friends, with your class fellows, with your teachers, so that it promotes my channel, and that helps me, and it is kind of appreciation for me. So thank you very much. I'm very glad that I am to some help to you. So thank you very much. Have a good day, and God bless you all.